So let me just summarize the main features. I'm going to go through these really quickly. You can actually configure the maximum information rate, the MIR, per subscriber unit. Enhanced QoS and 4-level queue per SU, that is coming with the next release, as well as the VLAN Q&Q feature. I talked about a long range. As you can see, 40 kilometers at 20 megabits per second. I think that's very admirable. As far as the radio performance, you will see that this system utilizes a very similar technology that Radwin uses in their point-to-point systems, which is the OFDM with 2x2 MIMO, which we all know helps a great deal in the near line of sight conditions. It also has enhanced interference mitigation capabilities. One thing about this product is how many of these sectors can I have on a tower. And this is also one of the main features and main characteristics of this system, where you can actually aggregate more bandwidth from a single tower than using different products from different vendors. You can have up to 16 sectors stacked on one tower, and this depends on the channel width you're using and whatnot, and I'll explain that. But theoretically, 16 sectors per one tower. They have to be synchronized to alleviate any self-interference, and that's done by using the hub site synchronization kit. You can also combine that with an RW2000C, for example, which we also know can be synchronized. So it's fully compatible with the Radwin 2000C series, which can be used for a backhaul to feed the main site, or even as an extension to the system in case where you need more than 50 megabits per second to a single site. As I said, dedicated traffic bandwidth allocation, which ensures SLA and latency, guaranteed time slots per subscriber. So you can have 16 subsectors, 200 megabit each, 3.2 gigabit of net throughput from one cell site. That number is a little hard to reach. If you do a little math, to do 200 megabit, you have to use a 40 megahertz wide channel. You have approximately 22 available non-overlapping channels in the 5.x range. All of those are 20 megahertz wide. So if you go from 20 to 40, you're actually not going to have 20 channels. You're going to have less than that and have less than the 16 that you can hang off of the same tower. So we're talking about a dozen channels that you can use throughout the whole 5.x. If you have the ability to reuse some frequencies, if you mount, I'd say, on the side of the building and use the building as a shield, then you can reuse and shoot one south, one north, and be on the same frequency. In that case, you can have up to 16 and have them all synchronized. Typical latency is 4 to 10 milliseconds. You can see latency less than 3 milliseconds also. Worst case, that's about 18, which is dramatically less than latency on a WiMAX system, which averages from 30 to 40, even 50 milliseconds. Channel bandwidth right now, only 20 megahertz. With the upgrade, the 40 megahertz will be available, as I said, from 100 to 200 megabit net aggregate, and also the 10, so you can half that, which will give you approximately 50 megabit per second. If anyone has any questions, feel free to ask.
There are several questions in the chat box.
Let me see. Different channel widths. Yes, I explained that. Let me go back. No 365 US. It might be on the roadmap, but as of now, no. It's not going to be available in 365. 2x2 MIMO, yes. Dual polarity MIMO, and diversity will be added with the next release. Channel width only 20 right now, 40 and 10 with the next release. All subs in the sector will have the same channel width. Yes, they will all have the same channel width. So all the subscribers on one sector will have to follow the channel width of that sector. Almost like with the WiMAX system. If you set a WiMAX system to 3.5 megs, the subscribers have to be on a 3.5 meg channel width. Main characteristics, again, multi-band base station, so 4.9, 5.2, 5.4, 5.8 in the US. Same for the SUs. Very simple to deploy. Essentially, it's a small form factor base station that you hang on the tower, and you have two RF patch cables that go to a dual polarity 2x2 MIMO antenna. Fully integrated with Radwin legacy solutions. As I said, Radwin 2000, WinLink 1000 can absolutely coexist with it. common Radwin manager. So the Radwin manager that you use to deploy in the field to configure the radios, change configuration, back up the configuration, upload a new firmware, change the band, do this, do that. It's all the same software product. And also it's compatible with the Radwin NMS server. The uniqueness of this system is actually that the base station capacity is probably the highest in the market right now, 200 megabit per sector. It has the highest spectrum efficiency, which is good if you're looking at a quick ROI. Secures a service level agreement for demanding applications, vertical markets like MDUs, video surveillance, even mesh backhaul, also enterprise backhaul, and for wireless ISPs, it can be used for backhaul multipoint distribution, main site to remote towers, and then off of that, different technology to give that last mile either to a business user or to a access point site or to the end client. Latency, 3 milliseconds, typical 4 to 10, 18 max. Very compact subscriber unit in different flavors, so you can choose whether you want to use a highly directional antenna, which is about 1.2 foot by 1.2 foot, very similar to the Radwin 2000C, or a compact form factor antenna, 15 dBi, that has external end connectors for connecting an external antenna. Coexist with the Radwin PTP, which can be used as a backhaul or as an extension for higher bandwidth demands, range up to 40 kilometers. And it is truly a carrier-grade product, robust and also powerful enough to handle all the packets per second and data processing. I talked about the vertical markets a little bit, so I'm just going to expand on it a little bit here. As you can see, service providers looking to provide high-end business users, high capacity, and guaranteed SLA, perfect product for this. Rural or remote broadband connectivity, wireless ISPs can deploy this as an extension off of unlicensed or licensed main backhaul pipe. And also it can be used for private networks, connecting an HQ building with multiple remote offices. It can be used for utilities, higher education, government purposes, healthcare. Also, very good product for video surveillance in light of the fact that the subscriber gets guaranteed SLA and very, very low latency, which we all know it's crucial for video applications. And also one thing that doesn't say here, mesh backhaul. If you're relying on your mesh to deliver the bandwidth throughout your mesh cloud, you probably have multiple clusters meshed together, and then you're using inter-cluster communication also based on the mesh technology, which by now might be saturated. If you want to allow those clusters to breathe more easily, to inject more bandwidth, that's typically a problem with mesh networks, that they don't have enough injection points, enough gateways to pull the bandwidth from. This is a perfect product for that. You can put one of these, feed up to 16 clusters with one sector. So imagine if you put like 3 sectors at 120 or 4 sectors at 90, how much bandwidth you can deliver to these mesh clusters, for example. I'm going to stop here for a second and ask if anyone has any questions.
Hey, Vlad?
Yes.
This is the model. Can I make a comment about the 2.5 market?
Absolutely. Go ahead.
Okay. Someone asked earlier if there was plans for Radwin to support 2.5. As you probably know, they do on the point-to-point side. On the multi-point side of the market, right now, unless you're a university or you have some sort of leasing agreement with Clearwire or the big dogs who own 2.5, most of the manufacturers today have kind of held back their design and implementation of multi-point systems. I know this because I came from Alvarian just recently, about 4 months ago, and they had a real big ramp-up design for 2.5, and they kind of held it back because the market is not really expanding, it's actually shrinking. So if there are some still interested parties for 2.5, we can certainly take the names down and we can put it to Radwin and see what they think. But as far as availabilities of channels, there are very few and far between frequencies available for public use today. So that's all I want to make sure that you guys are aware of.
Okay. So let me show you a few examples here on how to use the HPMP 5000 from Radwin. As you can see, there are 2 different examples here where you have a sector, you're trying to feed some bandwidth to some corporate buildings or maybe even MDUs. You have a base station, 5200, and you have a couple of 3 different subscriber modules. With the SU range at about 2 kilometers, sector capacity is 95. In this case, you have 7 clients and 5 megabits, 4 clients and 10 megabits, and 1 client at 20 megabits. If you sum that up, you'll see that that comes up to 95, which is not full capacity of the sector by no means. You can still add more. This is just an example on how you can connect these subscriber modules. At 5 kilometers, we're looking at 7 clients, for example, at 5 megabits per second and 2 clients at 10 megabits per second. Also an example of combination of different subscriber modules within the sector. As you can see, there are 2 different models of operation. The WLAN model, where traffic from the branch to branch is switched back by the base station, and the access model, where the higher network hierarchy actually switches the traffic. This model depends on the application. However, it's good to know that you can have that capability built into the base station, at least in one of these cases where you need to do something simpler.